This video demonstrates the increased fire hazard caused by obstructed or misaligned flue spaces within rack storage when the storage is protected by sprinklers installed only at the ceiling level. Vertically aligned flue spaces of a proper width throughout the height of the rack storage arrays, as noted by the pair of blue lines, allow for the heat from a fire to vent vertically, as represented by the red arrows, as quickly as possible, while at the same time slowing down the horizontal flame spread. This in turn allows for the ceiling level sprinklers to operate as quickly as possible. With the flue spaces vertically aligned, water discharged from the ceiling sprinklers has a path through which it can penetrate downward through the rack to attack the fire and bring it under control. Conversely, flue spaces that are either blocked or not vertically aligned, whether it be due to material handling supports, rack structural members, the storage itself, or other similar types of obstructions, impede the ability of the heat from a fire to vent vertically in a timely fashion. This not only delays ceiling sprinkler activation, but even worse, allows for faster horizontal flame spread. Without a vertically aligned path for ceiling sprinkler discharge to penetrate down through the storage rack, horizontal flame spread can outrace the ability of ceiling sprinklers to keep up with it, thus resulting in an uncontrolled fire scenario. FM Research has conducted several full-scale fire tests over the past few decades, confirming that blocked or misaligned flue spaces can result in an uncontrolled fire. While FM videotapes these fire tests, the dense black smoke emitted from these fires unfortunately blocks our view of seeing how the flames within the storage array spread horizontally. Fortunately, FM Research has developed a computer modeling platform that can simulate full-scale fire testing. We can use these computer simulations to demonstrate how the fire behaves in a storage rack equipped with adequately sized, vertically aligned flue spaces and compare it to a simulation where the flue spaces have been misaligned. In the two side-by-side videos you see on this slide, both simulations involve 35-foot-high, double-row rack storage of cartoned, unexpanded plastics in a building where the ceiling height is 40 feet. Ceiling-level sprinklers have been provided and consist of quick response K16-8 pendant sprinklers installed on 10 by 10 foot spacing and arranged to operate at a constant pressure of 52 psi. It should be noted that the simulation is limited in size to a rack that is 2 pallet loads deep and 6 pallet loads wide. In a real-life situation, the rack where the fire originates would likely be much wider and have adjacent storage across aisles on either side of it. It is apparent almost immediately that the misaligned flue spaces in the video on the left delay the vertical fire growth as compared to the vertical fire growth rate observed in the video on the right. At 14 seconds after fire ignition, the video on the left is demonstrating the impact of unwanted horizontal flame spread caused by the misaligned flue spaces, whereas there is minimal horizontal flame spread at this point with the presence of vertically aligned flue spaces shown in the video on the right. With vertically aligned flue spaces as shown in the video on the right, the first ceiling sprinkler operates at about 27 seconds. With very limited horizontal flame spread at this point, sprinkler discharge can penetrate down through the entire height of the storage array and start to control the fire. Meanwhile, in the rack on the left, the vertical fire growth has been delayed, thus allowing for more involvement of the plastics within the cardboard boxes to be ignited. This results in a larger fire compared to the fire on the right, and subsequently a much higher fire challenge for the ceiling sprinklers to control. While the first sprinkler to operate in the simulation with vertically aligned flue spaces took place at 27 seconds, it is not until 43 seconds after ignition that the first sprinkler on the left can operate. Nearly a minute into the fire, it is becoming clear in the left video that the delay in the sprinkler operation has greatly impacted the ability of the ceiling sprinkler system to adequately protect this fire. The misaligned flue spaces have resulted in a much larger fire and has increased the time it will take for sprinkler discharge to penetrate down through the entire height of the storage array. In contrast, with vertically aligned flue spaces on the right, the ceiling sprinkler system was able to operate in a timely fashion and discharge enough water down through the storage array to stop horizontal flame spread, thus resulting in a controlled fire. Although only 2 sprinklers have operated in the left video, it is apparent that the fire is continuing to grow larger. The fire on the left is now getting large enough to operate additional ceiling sprinklers. And not long after 2 minutes into the fire, several ceiling sprinklers are starting to open due to their inability to put enough water onto the fire to bring it under control. At the 2-minute and 15-second mark, the computer simulation was terminated, as 15 ceiling sprinklers have opened and show no sign of being able to stop the horizontal flame spread taking place within this storage arrangement. In a real-world scenario, the fire would be expected to spread throughout the entire warehouse building, resulting in its complete loss. To summarize, as the simulations have demonstrated, obstructed or misaligned flue spaces can delay the ability of the heat from a fire from venting vertically. This, in turn, will delay the operation of the ceiling sprinklers, allowing the fire size to increase. In addition, it also increases horizontal flame spread and delays the ceiling sprinkler discharge penetration down through the height of the storage array. This ultimately can result in an uncontrolled fire event with a likely outcome of a complete loss of the warehouse facility. This all could be avoided with the provision of properly sized, vertically aligned flue spaces within the rack storage array.